So this is now, I'll zoom out of this. This is just the machine-dependent code, rendered slightly different, but it's essentially the assembly you just saw with the virtual registers still in place. And I can now render next to this, for every virtual register, the interval of code over which it's live. So these are the intervals rendered on the side here. If you had higher resolution, you could see this better. I'll zoom right out. Basically, you can get a better handle on where exactly your virtual registers are used within the code. And at the very last minute, I've actually got this working, I think. Famous last words. I've added this RP pressure parameter in here, and hopefully now if I render it and zoom out, yes. We now have an actual rendering. The font's a little bit small for you to see, but on the top, that's each of the physical register classes that are available on the target machine. And you can now see rendered alongside the intervals this map of exactly where the pressure gets so high that you would be potentially forced to start spilling.
What are the different colors that
So a black region has absolutely no demand for registers. It's basically a dead class that's not being used. They're not especially interesting to us now, but when you get more advanced register allocation techniques, you can potentially identify these and use them as fast spill space. So you can move if your floating point bank's not being touched, then you can use it as a dodgy quick place to store integers because you still get a bitwise copy out of it. So yeah, now we can scroll down the function and we can get a handle on exactly. Yeah. So that region is going to be horrible to allocate. But part of the reason that it's probably horrible to allocate is that I've got a bunch of these long intervals, and just because this interval here is live the entire time, that means it's holding a useful value, doesn't mean it's actually being used. It just means it was defined somewhere up there and is used somewhere down the bottom. But if in the middle there's nothing actually accessing this, then we could make life a lot easier if we opted to store this just after it was defined and load it just after it was used. But the allocator isn't smart enough yet to make these, what are they called, splitting decisions. So that's the other thing that I was working on this weekend, is hopefully we will soon be splitting these intervals. And that's the next step. So since there's some interest in it, I'll have to write up a blog post for the LLVM blog and post this code to the main line. So hopefully soon this will be a little utility that you can use to dump out for any function that you're compiling the machine code along with the register pressure. And yeah, hopefully we'll get fancier and fancier graphics in there.
So is this useful for other languages as well, or is it mainly aimed at the Haskell LLVM?
It works for absolutely any language. It's just running on LLVM machine IR, so anything you compile with LLVM, you can get this register pressure diagram with. Yep. Yeah, that's it.
Thank you very much.
That's awesome.
Right. Laptop's gone to sleep, and now you're going to see me in the face. Sorry, people on the internet. Make sure it's still working. Okay, I'm going to turn the lights back on.
Sure.
Right. So I guess that's the end of AusHac2010. Thank you all very much for coming. I was kind of worried when we first started that no one would want to come, and be like 3 of us, and it would be really pathetic. But no, it's been really great. We've got a lot of really good work done, and I'm very impressed with it. All the work we actually did, because you can see it on the board. All right. So, real work. this is no, totally not blocked up one bit at all. You can see we have our clear representation of lists, with the head and tail, and other such fun shenanigans. Okay, thank you all very much, and I'll see you all again next year.
This time next year.
This time next year.
Excellent.
Thank you.